So, we all know AI is pretty good at telling if a product review is positive or negative. But what if it could do more than that? What if an AI could not only give a thumbs up or down, but also highlight the exact words that led it to that decision? That's what we're going to dig into today. Building an AI that doesn't just classify sentiment, but can actually explain itself.
And this right here is the core challenge. How does an AI handle a sentence with mixed signals? I mean, take this review. The acting was brilliant, but the plot was a complete disaster. As humans, we get it instantly. Brilliant goes with acting, disaster goes with the plot. But for an AI, how does it learn to connect the right words and balance those conflicting signals? This is where a lot of standard models can get a little confused.
So, to solve that puzzle, the model can't just look at words one by one, in isolation. Not at all. It has to understand how they all relate to each other, just like we do. It needs a way to see the entire sentence and grasp the full context all at once.
And how does it get that kind of deep contextual awareness? Well, the foundation for this is a tool called a bidirectional lstm. Think about how you read a really complex sentence. You might read it forward, then maybe scan back to see how the beginning connects to the end. That's pretty much exactly what this model does. It analyzes the sentence from left to right, and then it does it again from right to left.
Okay, so it's a two-step process. In that first pass, the forward pass, the model reads from left to right. As it goes through each word, it's building up an understanding based on all the words that came before it. It's capturing the initial flow and meaning of the sentence. And then, you guessed it, the second pass goes the other way. The backward pass reads from right to left. Now, this might sound a little weird, but it's absolutely crucial. It allows the model to give every single word additional context from all the words that come after it. So when you combine those two views, the forward and the backward, you get a complete 360-degree picture. This whole process creates a really rich digital fingerprint for every word, representing its full context within the sentence. It knows what came before and what comes next. But even with this awesome map, a key piece is still missing.
Right. This is the crucial question. We've got this super detailed map, but we need a spotlight. How does the model learn to focus on the important words like disaster or brilliant and kind of ignore the less important ones like the or was?
The solution is a really powerful and frankly, elegant mechanism called self-attention. And the best way to picture it is to imagine giving the AI a whole set of highlighters. Its job is to read that fully contextualized sentence and just mark up the words and phrases that are most important for figuring out the overall feeling.
So yeah, it's literally learning to pay attention to what matters most. A bit more formally, self-attention allows the model to calculate an importance score for every word in relation to all the other words. It learns to zoom in on the parts that are most critical for the task at hand, whether that's sentiment or something else. So how does the model actually use those highlighters? Well, it all starts after the sentence has already been run through that bidirectional lstm we just talked about. That's what gives us the rich contextual map for every single word to begin with. Then, the self-attention layer looks at that entire map at once. It compares every word to every other word, and it's basically asking, how important is this piece to the final puzzle? And based on that analysis, it assigns that importance score to each word.
And those scores are what determine the final outcome. The whole process gives us a final intelligent summary of the sentence. You can think of it as a weighted average, where the words the AI highlighted with high importance scores have a much bigger influence on the final positive or negative decision.
But this brings up a new question. What's to stop the model from getting lazy? You know, it could just learn that the word horrible is a really strong negative signal and then just focus all of its attention there every time, maybe missing other important details. And that's the problem of redundancy. If we want the AI to truly understand a sentence, we needed to find multiple, complementary pieces of evidence. We needed to use its different highlighters to find different clues, not just use the same one over and over again on the most obvious word.
So how do you force it to look for more than one clue? The solution is a pretty clever trick called a penalization term. During training, we add a rule that essentially penalizes the model if its different highlighters all focus on the same word. This encourages them to spread out and find diverse clues for the sentiment.
And does that make a real difference in practice? Oh, a huge difference. The result is crystal clear. Without this penalty, the model might just highlight repetitive words like horrible and awful. But with the penalty, it learns to find distinct, meaningful phrases like horrible service and will never go back. This leads to a much richer understanding.
Okay, so this has all been a little abstract so far. But I said at the beginning we could see the AI's work. Is that actually possible? It absolutely is. And that's the most exciting part of this whole approach. It's not a black box. We can actually visualize those attention scores to see exactly which words the model decided to highlight. Let's look at some real examples.
Let's start with a classic negative review. I will never go back to this place, horrible service. For us, the negative feeling is pretty obvious. Let's see what the model thinks.
And look at this, the model correctly identifies the two most critical phrases. It puts a heavy focus on never go back and on horrible. So it didn't just find one keyword, it found the two key concepts that really drive that negative sentiment. That's pretty impressive.
All right, let's try a positive one. The food was perfect and the server was so kind it made our night. Again, an easy one for a human to classify.
And the AI nails it again. It highlights perfect when talking about the food and so kind when talking about the server. So it's not just classifying the sentence as positive, it's showing us the actual evidence it used to arrive at that conclusion. This kind of interpretability is a huge step forward.
So, let's bring it all together. What are the most important things to remember from all this? Well, the biggest takeaway is that these complex AI models don't have to be mysterious black boxes. By using bidirectional lstms for full context and then layering self-attention on top as a smart highlighter, we can actually see why a decision is made. And by adding that penalization term, we make sure the model finds diverse, meaningful evidence every time.
And this leaves us with a fascinating final thought. We've built these tools to better understand text, but now that these models can highlight what they find important, they might just start showing us patterns in our own language that we never even noticed. What will we learn about ourselves when we ask an AI to show its work?
It's a powerful question. If you found this explainer helpful, please do like, share, and subscribe for more deep dives into these kinds of topics. Thanks for joining us.